Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. In this particular video, we're going to learn the process of rationalizing the denominator of a radical expression, particularly a one-term radical expression. So let's go ahead and take a look at this. So there are several reasons you might want to rationalize a radical expression. The primary reason back in the day was before calculators, it was very difficult to deal with denominators that had a rational expression, like the square root of 3, square root of 2, etc. Another reason is that when you get into more advanced levels of math, trigonometry, calculus, pre-calculus, whatever, when you have to move things around for algebraic purposes in order to complete an equation or whatever, or an expression, sometimes it is useful to rationalize the denominator. Now let me give you an example of what I'm talking about so I can remove the theoretical aspect of this. So if we go right here, let's say I have 5 over the square root of 3, like so. Again, this could be a problem, in terms of calculation or in terms of further analysis if you're doing something algebraically. And so to overcome this, what we do is we multiply the top and the bottom by the denominator. Now there are some exceptions to this and we will learn about that in a moment. But when you complete this process, you will get the following. You'll get 5 times the square root of 3 over 3, because the square root of 3 times the square root of 3 becomes 3. And you can check this if you want on a calculator. So if you just want to bring my calculator over here, you can see as follows. So let me do the first example right here. 5 divided by the square root, let me put that in parentheses, square root of 3. You can see we get 2.886. Now I go ahead and I clear out, and now I do the following. I do 5 times the square root of 3 divided by 3, and I get the exact same number. So we know this works. Now, having said that, let me show you an example that's a little bit more advanced that you can see here, how this can become much more complicated. Imagine that I have the following. I have 5 over the cube root of 9y. Now, the first thing you want to do in this particular situation is you want to show the factors. So as you can see here, let me get rid of that equal sign. I prefer just to that. So 5, and then what are the factors of the cube root of 9y? Well, you got the cube root still, and then underneath that you would have 3 squared, and you would have times y. That's what we have here. Now, what we need to do now is that we need to multiply the numerator and the denominator by something that will give us a perfect cube square. And so in our particular situation, that perfect answer is going to be as follows. And I'm going to explain this in a second. Let me just set it up for you, and then hopefully this will make more sense. So we got the cube root of 3 times y squared. And then above we have cube root of 3 dot squared. Now what am I doing here? This is what I'm doing. If I multiply, remember that I need a perfect cube. Everything I'm doing needs to be a perfect cube because I have a cube root here. So if I take 3 squared times 3, I'll get 3 to the third power. If I take y times y squared, I will get y to the third power. That is why I'm doing that. And so whatever I do in the bottom, I do above. I do the same thing above. So technically, I don't take this. Instead, what I do is I take something that will give me a perfect cubed. That is what I'm doing in this particular example. Now, in the prior example, I could just take the radical straight across, because by multiplying these two together, I would get a perfect square. That's what was happening in the previous example. But in this example, it's a slight modification. Generally, what happens is that your exponent needs to be 1 less the cube root. That's kind of how it works out. That's kind of the little secret. Now, when I do this, I get the following as my answer. Just going to draw my arrow down like so. I get 5 times the cube root of 3y squared, all that over the cube root of 3 to the third power, y to the third power, like so. And then when I complete my process here, just going to draw my arrow across like so, I get the following. The top does not change. The numerator is finished. So 5 times the cube root of 3y squared, but you probably know what's going to happen with the bottom number. All this is going to cancel out and we're left with 3y like so, and that is our answer. So you can see how you have to make some adjustments depending on the original format of your expression, your radical expression. But in this particular instance, we were able to complete this. So let's go back and see if we can summarize what we've learned and try to simplify this as much as possible. So we're learning how to deal with rationalizing the denominator of radical expressions. And so with a simple example takes a simple approach. When you have a square root like so in the bottom, you just multiply the top and the bottom by this denominator and you get your final answer. When you're dealing with higher levels, or higher exponents, if you will, the process is slightly different. You have to keep in mind whatever the original index was, and then you want to try to make a perfect cube, a perfect fourth, a perfect fifth, or whatever of that situation. And so in this particular example, what we had to do was that you could see here that we had the 3 squared here, but we didn't need that over here. Well, we had the 3 squared here, excuse me, and then over here we only had the 3 because 3 times 3 will give us 3 cubed. I hope I'm not losing you. And so what you're trying to do is you're trying to make it so that you have a perfect cube or a perfect fourth doing whatever you need to do. So we ended up with this information right here after we have factored out our radical expression, and then we just multiply straight across, and then we'd simplify by eliminating whatever was necessary to get our final answer. Now this is very, very tricky. So keep in mind that when you're dealing with higher levels is that you want to make sure that when you are looking for what to multiply by, that it comes out to a perfect cube, or it comes out to something that satisfies the index. So 3 squared times 3 is going to be 3 cubed, and that'll become 3y over here. Y times y squared becomes y to the third. Again, with the cube, you come out with the y at the end of it, and that's how it needs to be. So I hope this video was useful for you and that this was clear and things made sense. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.